I welcome all the students. Today we are going to discuss the point or the topic that was related to the projection, and we are going to learn the two important types of projection. One is parallel projection and the second is perspective projection. Okay, so today's our topic of discussion is parallel projection and perspective projection. Okay, so these are the two things that we are going to learn today: parallel projection and perspective projection. Okay, and after completion of this we are going to discuss the next point. In today's topic, first I'm going to learn the three-dimensional display method. Okay, so before I start with the projection, I've added this point so that it will be clear that how we are going to consider, which view that we are going to consider, and which is the plane that we are going to consider. Okay, so the point that I have putting at the start is three-dimensional display methods. Okay, three-dimensional display methods. Now, to obtain a display of a three-dimensional scene, I want to obtain a display of a 3D scene, okay, that has been modeled in a world coordinate. We must first set up the coordinate reference, okay, for a camera. Okay, so I consider that what is the position of my camera that I must consider, and that is going to be important. Now, this coordinate reference defines the position. So this coordinate reference defines the position and orientation, okay, for the plane of the camera field, which is the plane we want to use. Okay, I want to take the photo from which angle, okay, from which position I want to take it. Okay, I want to take or capture the 3D view. So which is the plane we want to use to display a view, the object in the scene. Okay, that is considered to be very important, and we have to consider this. Okay, so I have shown this with the help of one diagram. Okay, so everyone understand the diagram, what this indicate. Okay, this diagram indicate the coordinate reference for obtaining a particular view of a three-dimensional scene. Okay, you can find here, okay, this is my object. I want to capture this 3D object. Okay, now to capture this 3D object, okay, this is my position of my camera. I have decided this is the position of the camera or the view position. Through this I am going to capture the picture, and if I consider the whatever the rectangle that I'm having, then I come to know that this will be indicate, or this is the thing which is going to indicate this is my display plane. Okay, so this particular rectangle that I'm having, or I call it as this is my window, okay, that I'm having in my world coordinate system, which will define the display plane. Okay, three-dimensional display plane is defined, and this camera will gives me the position as well as the orientation of the plane. Okay, so depending upon from where, which position and which orientation I'm capturing the picture, I will get the a similar three-dimensional picture will be displayed on my screen. Okay, so just for the basic concept understanding, I have shown this diagram so that you came to know that, or it will be easy for you that you are capturing the three-dimensional picture from which view. Okay, that is considered to be what is the display method that you are using is considered to be important, okay, in the projection, because our today's topic of discussion is related to projection. Okay, and we are learning the two types, what is the parallel projection and perspective projection. Okay, so that's why I have added this initial diagram so that you will understand how we are capturing the picture, that position of this camera as well as the orientation is important, which is going to form my display plane, or which is going to form this window in the world coordinate system. Okay, so with this discussion, let us move to understanding the types of projection that we are having. So first of all, we are going to learn what is meant by the parallel projection and what is meant by the perspective projection. Okay, and after understanding these two basic things, we are going into the detail of parallel projection and perspective projection. Okay, Let us understand how we can achieve the parallel projection. One method of generating a view of a solid object is to project points on the object surface along a parallel line onto the display plane. So I'm just going to take the parallel lines onto the display plane. So that's why it is known as the parallel projection. Okay. By selecting different viewing position, we can project the visible points on the object onto the display plane to obtain different 2D views of the object. Okay, so in parallel projection, by selecting the different viewing position, okay, so I just select my viewing position, maybe front side, back side, left side, right side, maybe top side or the bottom side. So I'm just going to select the different viewing positions, okay, and we can project the visible points on that particular object onto the display plane, okay, to obtain the different two-dimensional views of the object. We are getting from different angle, we are going to take the 2D views of that object, okay, which is shown below or which is shown over here. Okay, so we just consider that diagram also. Okay, first consider the diagram. Okay, so first consider the diagram over here. Okay, so this diagram shows the three parallel projection views of an object. Okay, so these are the three parallel projection views of my object. This is my original object, okay, which is a three-dimensional object. Okay, consider this is my three-dimensional original object I'm having. Okay, now for this three-dimensional original object, okay, if I'm taking the different viewing position, so my different viewing position may be top, and number of positions are possible, but I consider we are considering the front side, left side or right side, okay, as well as the side view, as well as the top view and the bottom view and so on. So basic three views that we have shown. The top view means if my projection position is coming from this side, so my camera is going to capture the image from this side, okay, so my top view. So how this object will look like from the top view, it's shown over here. So this is the top view of the object. I may take the object, okay, from the side view. I want to take the side view of the object. So where is my camera, where is my viewing position? My viewing position is in this direction. So consider that I'm capturing the image from this side, okay, side view. So then I will get, yes, this and this, maybe though it is having this, it is not comes over there. So I just have this line and I get this is my side view of my object. Similarly, I may get the front view of the object. I want taking the front side. My camera, I'm going to position over here. Okay, so this is my viewing position, okay, of the object. Okay, and then I'm just taking the parallel lines from this particular view to this particular object or the display plane. So that's why it is called as parallel projection. And now this is the front view I will get for this particular object. Okay, so I will get this particular side, definitely though it is, but in front side it will not appear as a straight. So I get this is my front view. Okay, so the point of discussion is in the three-dimensional object. Okay, if I'm considering this three-dimensional object and I'm going to take the different views of the object and how it will, and all these views display the two-dimensional views, 2D views of the object. I'm going to take 2D views of the object, then it is comes under the, or this is called as the parallel projection. Okay, now let us understand one more point that we have just considered. Parallel lines in the world coordinate scene project into the parallel lines on the 2D display plane. Okay, so whatever the parallel lines I'm having in the world coordinate system, I'm just going to consider all these parallel lines onto the two-dimensional display plane. So that is what I told, it is called as the parallel projection. And very important part is it is applicable or it is used in the engineering and architectural drawing. So parallel projection is used in the engineering as well as it is used in architecture drawing. So whenever we are going to design the we are going to take the design of the building. So generally we have this 3D object of the building. We can show what is the top view of the building, what is the side view, front view, okay, bottom view or back view and so on. So all this comes under the, or this is the part of the parallel projection. Okay, so let us understand now. If this is parallel projection, now we are going to understand what it means by the perspective projection. Okay, because initially I'm just going to differentiate between what is parallel projection and perspective projection, and then we are going into the details of all this projection. Okay, now we are going to consider the perspective projection. Okay, we are going to learn the part of the what is mean by the perspective projection. We have already learned the part of the parallel projection. Okay, we have learned what is mean by parallel projection with the help of the diagram. We are considering what is the perspective projection. Okay, now this method of generating a view of a 3D scene is to project points to the display plane along converging path. Okay, so this method is different than the parallel projection. Okay, now this particular method causes the object which are farther from the viewing position. The object which are at the longer distance from my viewing position, okay, will be displayed smaller, will appear smaller than the object of the same size, that are nearer to the viewing position. Okay, so which are near or which are closer to the viewing position, their size, it will appear that the size will be larger. Okay, whereas the object which are at the farthest position or the longest distance from the viewing position may be displayed as a smaller. Okay, now just let us understand this with the help of the example. Okay, so concentrate on this particular example. See, this is the image of or it is a perspective projection view of an airport scene. Okay, so on an airport scene we have taken this perspective projection view. Okay, then what will be observed by you? What you observed over here, we can find this is my one aircraft or the plane which is closer to my viewing position. Okay, which is closer. So we can find that the size of this particular object or the size of this particular plane will be displayed in the image, which is very large. Okay, so it is very large. Whereas I can find that this is another aircraft of the plane. Okay, actually the size of this object, this plane and this plane is actually, it is the size is same, the actual size is same. Getting me? But as this particular aircraft or the plane is at a longest distance or the farthest distance from my viewing position, so this will be appear as a smaller. Okay, so we may consider or may feel that this particular aircraft or the plane is of the small size and this may be of the larger size. Okay, so that is what happens in the perspective projection. Even you can find that the runway area that I'm having, okay, here it may be of the larger size, but if I move to this particular side here, you can find it may be of the smaller size because it is at the farthest distance. Okay, so this is, we are considering, this is the second type of the projection that we are having to display the 3D view, and that we call it as the perspective projection. Okay, but whatever this perspective projection we are having, it is also have the advantage, it is having the advantage as compared to the parallel projection. And what is that advantage? Let us understand. See, this is my third point of discussion. The scene displayed by the perspective projection appear more realistic. Okay, my image or my scene are more realistic since this is the way our eyes and the camera lenses form the images. Okay, so if we are looking, okay, so assume that you are at the airport, okay, and you are finding, you are just capturing this image or this scene that you are finding with your human eyes. I think it will be exactly same or more similar as is displayed over here. As well as if you want to capture it with the help of the camera lenses, I think the view will be more similar. Okay, because the same thing happens with the human eyes as well as with the camera. So that's why we can say the perspective projection. Okay, the advantage of perspective projection is that it always displayed, the scenes which are displayed with the perspective projection are realistic scenes or realistic images. Okay, so I hope all of you have learned or understood what is the difference between parallel projection and what is the perspective projection. Okay, now let us start understanding all these two types in detail. Okay, so I'm just moving to the next slide to start understanding the parallel projection in detail. And at the end of the session, we again go through this perspective projection in detail. Okay, we are going to learn this in detail. Okay, so this is my slide. Okay, so let us start understanding the parallel projection in detail. As we have said, okay, in parallel projection, okay, coordinate positions are transformed to view the plane along a parallel lines as shown below. Okay, so we just consider that diagram also. Let us move to the second point. A parallel projection preserves the relative proportions of the object. This is one of the major advantage of the parallel projection. Parallel projection preserves the relative proportion of the object. So all object and their proportionate size, okay, will be maintained, or their propositions of that objects are maintained into the parallel projection, but they are not maintained in the perspective projection. Okay, and this is the method which is used in the drafting to produce the scale drawing of the 3D object. Okay, so that for that purpose we are using the parallel projection. Okay, the accurate view of various sides of an object are obtained with a parallel projection. So this parallel projection is useful to accurately view the various sides of the object I can find out or I can obtain with a parallel projection. Okay, now I think we have discussed this as my first point. So let us understand this diagram with respect to the first point. In parallel projection, coordinate positions, see, coordinate positions are transformed to a view plane along parallel lines as shown below. Okay, so here you can find it as the same diagram I have shown here, the parallel projection of an object to the view plane, parallel projection of an object to the view plane. Okay, see here you can find this is my, I call it as my view plane. Okay, this is my view plane, and I'm having these 2 points P1 and P2. Okay, so these are the 2 points I'm having, P1 and P2, and how this line and this line P1 and P2 are connected with the line, how it will displayed on my view plane. Okay, this is my view plane. How it is displayed on my view plane? What we are going to do, we are just going to have a dotted parallel lines. You can find this is my parallel line. I'm just taking this parallel line and I'm projecting this on my view plane, and this will be P is displayed as P1 dash and this is displayed as P2 dash. So this is my actual view of this on my, with the help of the parallel projection. Okay, so this diagram has clear your concept how I'm taking these parallel lines and how it is and the things are displayed on my view plane. Okay, so let us continue our discussion about the parallel projection. There are the types of the parallel projection. So let us understand which are the different types of parallel projection. When a projection is perpendicular to a view plane, when I'm going to take the projection which is perpendicular to a view plane, it is called as, or which is called as orthographic parallel projection. Okay, when I'm going to take a projection which is perpendicular to the view plane, okay, we have, it is called as the orthographic parallel projection. Otherwise, okay, if I'm not taking the perpendicular, okay, it is not perpendicular, then we have call it as the oblique parallel projection. Okay, it is called as oblique parallel projection if the projection is not perpendicular to the view plane. If it is perpendicular to the view plane, we call this term as orthographic parallel projection. Otherwise, we are calling it as the oblique parallel projection. Okay, so let us understand this difference with the help of the diagram. So the following diagram shows these two types of parallel projection. Okay, so which are these two types of parallel projection? One is orthographic projection and another is oblique projection. Okay, so here you can find the orthographic projection, that is my diagram number A. In orthographic projection, you can find here this particular line that I'm considering, which is this, and this is my scene, okay, that I'm going to capture. So I can find that the projection is perpendicular to the view plane. Okay, my projection is perpendicular to the view plane, so that's why this is called as orthographic projection. Whereas here you can find, okay, this is not perpendicular, it is having some different angles. Okay, so it is not perpendicular, so it is called as oblique projection. Such type of projection is called as, they are calling this as a oblique projection. Okay, so this two diagram shows when I'm having a projection is perpendicular to the view plane, I call it as my orthographic projection. So this is my orthographic projection, and this is not having the perpendicular line or perpendicular view. I'm not having, so it is called as, comes under the oblique projection method. Okay, so continue our discussion. Let us move to the slide now. Now we are talking about orthographic projection first. Okay, because this is the first type of parallel projection. Okay, now, the orthographic projection are most often used to produce the front view, side view, and the top view of the object. So, in the orthographic projection, we are going to, often it is used to produce the front view of the 3D object. We are going to take the side view of the 3D object, or we are going to take the top view of the object. Okay, and this front, side, and rear orthographic projection of an object are also called as elevation. Okay, so I'm going to take the front, side, and the rear views of this, and that is generally called as elevation. But when I'm going to take the top view of the object, then it is called as a plane view. Okay, so now we are discussing about the orthographic projection. Okay, now in this particular, this orthographic projection where I'm taking the front view, side view, top view, okay, of the object, all these are useful for the engineering and architectural drawing. Okay, they are useful for engineering and architectural drawing, and commonly employs this orthographic projection. So all the engineers, architectures, okay, for drawing purpose, okay, they use the orthographic projection. Okay, now this is what I have shown in the diagram. I think this diagram will help you to understand the orthographic projection. Okay, now you can find here in this diagram, this is my three-dimensional object. Okay, this is my three-dimensional object. You can find, to draw this view, everywhere I have taken the parallel lines. Okay, connected lines I am taking, and that's why it comes under the parallel projection. Here you can find, suppose this is my object, and I'm taking the front view of the front elevation view of this particular object. Okay, then if I'm just having these lines connected with each other, then we come to know that how this is displayed. So this object, 3D object, now it is displayed in this particular way. So this is the front view of the particular object. Okay, if I take the side view of this particular object, which is shown in the diagram, you can find this line to this line is connected, this is connected. Okay, you can find it here, this is connected, these are the dotted parallel lines I am having. Similarly, I am having these dotted parallel lines over here, and I can form this my side view of the object. Okay, I call it as side elevation view of the object. Okay, similarly, okay, I'm going to take, or I'm take, this is my top view of the plane. Okay, generally top view is called as the plane view. That is what we have written. Plane view means it is my top view. Okay, you can find all these parallel lines are connected, and my object will look from the top, or for the plane view, something like this. Okay, so this is my top view or the plane view. This is considered to be the front view of my 3D object, and this is going to be my side view of the object. Okay, and whenever I'm going to take this, okay, this is something which is called as the orthographic projection. Okay, so we are considering it as the orthographic projection, which is a part of my parallel projection method. Okay, so continue our discussion of the parallel projection in detail. Okay, now here one more thing that we are going to consider at this is the orthographic projection that display more than one face of an object are called as axonometric orthographic projection. Means my orthographic projection that display more than one face of an object. Okay, so I'm looking to it from more than one face or more than one angle, then it is called as axonometric orthographic projection. And the most commonly used axonometric projection is something which is known as isometric projection. Okay, so actually, as it is applicable to the computer graphics, we are learning this type of the projection, but generally the engineering student will learn this more detail how to draw it in the engineering drawing. Okay, so whenever you learn engineering drawing, I think the students have learned all these types of the views in detail, but all this should be included in my computer graphics package. In our computer graphics package must support all this. That's why we are learning all this projection, parallel and perspective projection. Okay, so the most commonly used axometric projection is called as or it is my isometric projection. Okay, let us understand this with the help of the diagram. So this is my isometric projection of a cube. Okay, so I consider this is my cube, or that I'm having my object. Okay, now here you can find that I'm just taking this object from the different faces of an object or different angles of the object. So I think here I can cover the front side as well as the top view of the object is also displayed in my view plane. Okay, so the object is viewed from the more than one face of the object. I'm not taking only the front view, only the side, but I'm looking toward the object with more than one face of an object. Okay, so that we have learned, and this is my the view plane that I'm having. Okay, so which is displayed in this particular case. So this is indicate the example of the isometric or isometric projection. Okay, which is comes under the part of the parallel projection. Okay, or under parallel we are having orthographic projection, and we are also having the oblique projection. So under orthographic projection we have seen the previously how it will look like, and now the orthographic projection, one special case or most commonly used one of the type of the orthographic projection is isometric projection, and this diagram shows the example of isometric projection. Okay, so let us continue our discussion to understand the next type of this, that is the oblique projection. So we have learned there are the two types of parallel projection: orthographic projection and oblique projection. Now an oblique projection is obtained by projecting the point along a parallel line that are not perpendicular to the projection plane. Okay, the lines which are along the parallel line that are not perpendicular to the projection plane, then we call it as a comes under the oblique projection. Okay, in some application an oblique projection vector is specified with two edges, okay, alpha and phi. Okay, so with the help of these two edges we can specify. Okay, now the point x comma y comma z, so the point in the three dimension x comma y comma z is projected to the position. So my position will be xp comma yp on the view plane, which is projected, and now how it will looks like. So let us understand the diagram to understand the oblique projection. Okay, so oblique projection of coordinate position xyz to the position xp comma yp on the view plane. Okay, so you can find here I'm having this view plane, this is my zv or view plane. In the v indicate view plane I'm having, this is xv, this is yv. Okay, now I'm looking to, this is my view plane, to this view plane. Okay, whatever I'm having, this is my view plane, this complete with color which is shown with my view plane. I'm looking to this particular object or the three-dimensional object having the value x, y and z. Okay, so x, y, z, through x, y, z, this three-dimensional point or the object is visualized, and now I am looking to this particular point from this particular angle. Okay, so I'm having looking to this particular with the I'm having the angle which is there, that may be phi as well as the alpha that we are considering, and I may or we will be in a position to change these angles also. Okay, so we are in a position to change all these angles to get the appropriate image of the oblique projection. Maybe 30 degree, 40 degree, 50 degree, we can change this angle to view this particular point or the object in the oblique projection, and definitely it is not perpendicular to the projection plane. That's why we can change this angle maybe 30 degree, 40 degree as per our requirement, and we can find out the particular object. Okay, now let us to show this. Okay, we are having one more diagram I've just show just to understand this oblique projection, that how we are going to take it. Okay, let us continue our discussion. Okay, so I have directly have shown the diagram. I want everyone to just concentrate on this so that we can get the oblique projection. Okay, so this is the oblique projection of a box onto the zv is equal to 0 plane. So zv value I take it as a 0 plane. This is my original object A, original coordinate description of the object. This is my ZV, YV and XV. Okay, which stand for the view plane in this particular case. Now what I'm going to do here, I just considered I'm having this box, and here I'm having this Z will be shown as with the dotted line. Okay, so these are the dotted lines are there, but I just take ZV is equal to 0 plane. So this is my projection on the viewing plane. Okay, so I will not find this particular Z value. I'm not considering it is 0, so this will not be displayed. So I'm just getting this part. This is the top part, this is another side part that I'm having. Okay, so and this is my angle phi. So I'm having this angle as a phi that will be displayed here to get it. Now this angle phi that I'm having may be changed accordingly. So what I say phi is equal to 45 degree, okay, I will get this particular object. Okay, if I just say that phi is equal to only 30 degree, okay, my view will display the diagram number B for the same object. Okay, so in this case or in this way, it is possible for us to change this phi value or the angle value to view this object or to take the different angles of the particular object and their different views that we are going to take it. Okay, so this is what, so in this way we have learned the two important types of the parallel projection. One is orthographic projection and another is oblique projection. Okay, so this is what our discussion of understanding the parallel projection in detail. As all of you are knowing, it is applicable where this will be useful. This is useful by all the engineering and architecture or everywhere we want to have the drawing, then we will use this parallel projection, which gives me the front view, side view, top view and the different views of that particular object. Okay, how it will views, okay, or how it will be looks like. Okay, and that is achieved with the help of my parallel projection. But here I want to mention the drawback of the parallel projection is the parallel projection are not suitable for the realistic images. Okay, for realistic scene or the natural scene, it is not that much suitable. Okay, so that's why we are use the, in such cases be better to use the perspective projection, not the parallel projection. Okay, so that's why now we are started. Let us move to the next point where we are going to learn the perspective projection in detail. Okay, so let us move to the next slide to understand this. Okay, so start discussing about, our discussion is now about perspective projection. Okay, so perspective projection. For perspective projection, object positions are transformed to a view plane along the lines that converge to a point called the projection reference point. Okay, so from this projection reference point, okay, all this plane, okay, all the lines of the view planes along the lines will be converged to a point which I am calling it as my reference point. Okay, so here we are not taking all the parallel lines of the original object to the view plane. Okay, similar to parallel projection, so that's why we are considering that the perspective projection. Okay, so just look at the diagram. This is my perspective projection of an object to the view plane. Okay, now this is my view plane. You can find, yes, this is my view plane. You can find it here in this diagram. This is your view plane which is just now shown. Okay, and now this is my actual line. So I am having the point P1 and P2 and this is my line. Okay, but now I am not taking the parallel lines of this. I'm not taking the parallel lines. I'm taking that all these lines when at this point. So this is my the projection reference point, and I'm just see that when this all this P1 and P2 points were matches were here, and from this point I'm looking to it, so it is not taking the parallel lines. So my though, okay, considering the distance here, considering the distance, my line will be displayed something like this, okay, on my view plane. Okay, so this is what the perspective projection of an object that we are having. Okay, so let us consider the next point. Now this perspective projection produces the realistic views. Okay, it produces the realistic view but does not preserve the relative proportion. Okay, so this is the drawback of the perspective projection. It produces the realistic views but it not preserve the relative proportion. Okay, now for that I think this also shows that maybe here the actual size of the or the length of this particular line P1 and P2 point, the line may be more, but on this view, I think it has displayed as the small line. So I'm not taking the exact proportion of my original object will not be displayed on the view plane. View plane will not display the relative proportions of the object. Okay. Now, if it is not taking relative proportion, then what is going to happen? The projection of a distance object are smaller. If the object is at the distance location, then its size will be displayed as smaller than the projection of the object of the same size that are closer to the projection plane. Okay, I think we have seen this also in the previous discussion with the help of the perspective view of the airplane. Okay, at the airport we have seen it, but we can see one more diagram for this for our understanding. Okay, so just look at this particular diagram. It will be easy for you. This is my view plane. Yes, this is my view plane here. Now this is my projection reference point. So this is my projection reference point. Okay, and now you can just look at this in the projection reference point. This is my one line. Okay, I'm showing this is my one line and this is my another line. Now here you can find the length of the both the lines, this line as well as this line. Both the length of this both the line is same. Okay, their proportion is same. Getting me? But as I'm just considering this is my projection reference point, I'm not taking the parallel lines. Okay, all these points will be converged at this particular point. This line is displayed on my view. This is the length of my line. But this line both are same, or rather I say this is having the higher length, but this is displayed on my, but it is farthest distance. The distance is more. Okay, so it is farthest from this view plane. Okay, or from this projection point. So this line will appear here as a smaller. So length of this line is small. Okay, why it is small? Because this particular line which is projected here, it is the farthest. I think that is what we have read. The distance is more, then it will object. This will appear as a small, and this will appear as a large line. Okay, but actually the both are having the same size, or rather this is having the more size. Okay, so that is what we want to show with the help of this particular diagram. Okay, about the perspective projection. Okay, let us continue our discussion of the perspective projection. I'm just moving to the next slide so that you will or everyone will understand the further details of the perspective projection. To obtain a perspective projection of a 3D object, okay, to obtain a perspective projection of 3D object, we transform the points along a projection line that meet a projection reference point. Okay, so I want that should meet to the perspective projection reference point. Okay, so that is what we have having. Suppose we set the projection reference point at the position ZPRP. Okay, so what is my projection reference point? Perspective projection of a point P with the coordinate XYZ to the position XPYPZVP on the view plane. Now here what I'm going to take is just look at this particular diagram. Suppose we set the projection reference point at the position ZPRP. So this is my point. Okay, so this is my point. I'm calling this is the my reference point of the projection. In the perspective projection, this is my reference point. Okay, now for this reference point, what is my angle that I'm having? So what is my position that I'm having is I consider in this plane, this is my XP, YP and ZVP. Why it is Z value? Because my Z view, okay, from the Z view I have taken this is my reference point, project reference point I have taken. So this is having the with this Z value is with respect to ZVP, and then this is my actual P point is this. My actual P point is X comma Y comma Z. But now that point will be appear here. Okay, and this point may have, or this point is, so X value will be changed to XP, Y value will be changed to YP, Z value will be changed to ZVP, considering this is my reference point. Okay, so considering this reference point, the values of this point, original point P, okay, on this view plane, okay, I'm considering this is my view plane, on this view plane may changes with respect to the reference point. Okay, and that is what we are going to show in this diagram, and that is what our topic of the discussion related to the perspective projection. Okay, so I hope all of you have understood the perspective projection in detail, and we have seen that the main advantage of perspective projection is it will be applicable or realistic images. Okay, but the drawback of the perspective projection is that it will not maintain the proposition of the object. It's not maintained. Okay, but still this particular projection is very useful, okay, for all the realistic images, and the view will be same as which is seen by our human eyes, as well as the image that I'm capturing with the help of the camera. Okay, so I'm having only one slide where we are going to discuss, I think, the similar perspective projection. Okay, we are having one more slide to point to be discussed, and then we conclude our session. Okay, so let us understand the diagram directly. So we are having what is mean by the vanishing point comes under the perspective projection. Okay, the point at which a set of projected parallel lines appear to converge, means the point where all these projected parallel lines are converged is called as my vanishing point. Okay, and each set of projected parallel lines will have a separate vanishing point, means there may be every set of the projected parallel lines will have the separate vanishing point. So I cannot say there is only one vanishing point in the perspective projection, but there are more number of vanishing point, or each set of projected parallel lines will have the separate vanishing point. Okay, and the vanishing point for any set of lines that are parallel to one of the principal axis of an object are called as principal vanishing point. Okay, so I'm having the vanishing point for any set of lines but that are parallel to one of the principal axis. All these lines are parallel to any one of my principal axis, maybe x-axis, y-axis, or z-axis, then of an object, then it is referred as principal vanishing point. Okay, so let us understand this with the help of the diagram and the further understanding. I want everyone to just concentrate on the diagram so that you will understand the perspective projection and you will understand vanishing point also. Okay, so a diagram shows this is my coordinate description. So I'm having this particular object. It is having, this is the x direction, this is in y direction, and this is the z direction of this particular original object. Now in the B, if I consider this is my vanishing point, if I consider this is my vanishing point, so all these lines, the parallel lines that I'm having, which are going to converge at this point. Okay, all these lines are going to converge at this particular point. Okay, so somewhere here, and now the one point perspective projection, my object will look something like this, because this is my one point of the vanishing point which I have considered over here. But as we have mentioned, there should not be only one. Each set of projection parallel lines will have the separate vanishing point, not necessarily only one. So here you can find, if I take this particular object, I take, these are the vanishing point over here. So this may be x-axis vanishing point, here I may have the z-axis vanishing point, and the I'm having my perspective view with the two vanishing point, two perspective projection point, perspective projection. So in this case, my object will be visualized, or it will look like something like this. Okay, so that is what my diagram or this last point explains. The perspective view and the principal vanishing point of an cube for a various orientation. So I'm taking with the different orientation of the view plane relative to the principal axis of the object. Okay, so I think actually there is no need for us to go into the more exact details of the perspective projection. So our aim of today's session is covered. Okay, that is, we should understand what is mean by the parallel projection, we should understand what is mean by the perspective projection. So these are the two main types of the projection: parallel projection and perspective projection. Parallel projection, as we have said, will give us the all different views of the object: front view, okay, then side view, top view, and so on, and this is more useful for the different engineering, architecture drawings, and everywhere it is. And main advantage is it will maintain the proposition of the object. So the same object size, its dimension, all these things will be maintained into the parallel projection. Okay. Whereas, and we have seen there are again the two types of the parallel projection. One is known as the orthographic projection, and another we call it as the oblique projection. Okay. So orthographic also having its again different type. Okay. So all this comes under the parallel projection. But parallel projection are not suitable for realistic images. So that's why we are having second projection or important projection, that is perspective projection. Okay. And we have seen that the perspective projection will show us the same image or same realistic image which is captured by the camera or which is seen by the human eye. Okay. But only the drawback or the disadvantage of the perspective projection that we are having is it will not maintain the proposition of the object. Okay, the object which are at the farthest distance will be looked as the small, and the object which are closer to my viewing position will be appear to be very large. Okay, and this is what our topic of discussion today. I hope all of you have seen the understand this with the help of the so many diagrams. Okay, and all of you have enjoyed the session. Okay, thank you. So we end our session over here. Okay, so we stop or end our session at this point. Thank you all the students.